Hello, uh, good evening everyone. I am Shubham Keshri. I am a PhD scholar in the Department of Management Studies in IIT Kanpur. So I welcome you all to this course, Hands-on Introduction to Python Programming Language. I have sent you the first course handout of this course, and I'll discuss the first course handout first before beginning today's lecture. And one more thing I wanted to tell you is that in today's lecture, we will not go in Python programming. We will have a brief discussion on what computational thinking is and some fundamentals of computer science. So today you may not expect any Python programming in today's class. One short announcement I had. So the course website has made live. So after this class, I will share the website link. You can all log in there and you can see the materials of the course, this PPT, as well as the recording of today's lecture. And in case you face any difficulty in logging in the website, you can text me and I'll see if I can arrange something else. If you guys face any difficulty, then I'll share one drive link also where I'll share the content of this course. So after you have tried to log in, then I'll check what to do next. All right. So let's go to the first course handout. So this is the first course handout which I had sent you earlier. I hope you have gone through the first course handout. Here I have listed down the course content. So mostly I'll not go through in this order. I'll try to grab concept here and there because it may be important to bring some concept earlier than some other. So here the order which it is mentioned, I may not go in the same order. And this will be a comprehensive course, mostly focused on beginners. If you don't have any knowledge or experience in Python programming or programming in general, you will benefit from this course. We will go on to some higher level concepts, but we will not dwell deep in concepts on which are not very important to our course, like these libraries, NumPys, Pandas. These are all data analytics libraries, and we will not go very deep in those libraries. So this course will mainly focus on the fundamental building blocks of programming, and we will use Python to program. So this will be what we will learn in this course. I have not yet decided what will be the duration of this course. So expectedly it will be around 30 hours, or it may increase or decrease depending upon what is the pace of our course. So you all know we will have a live discussion hour. So it may not be of 2 hours. We may have less than 2 hours also, but it will start at 6 AM on Saturday. And Sunday, I guess we will have a discussion. If you guys have any problem on Sunday, so we can shift that day. So we will have a discussion on that also. And yeah, so this is the assessment. So this is important. You have to have a good class participation to score well in the class participation category. And I will also give you some assignments after the class is after each section is completed, and that assignment will check how well you have understood the content of the course, and you will solve those problems and submit it, and you will be graded on that assignments. At the end of this course, just before the end of this course, you will be given a project, and you have to submit the project. It may be an individual project or group project depending upon how many participants are still there in the course, because I have seen initially there are many participants and the number decreases as the course progresses. So it will depend. It will be an individual project or group project, and you have to score a 60% minimum of 60% marks in the overall assessment for you to get a certificate by ISSS platform. And this project is mandatory part of this course. So you have to submit a project to get a certificate from our end. So books, I have just listed down one important book. I'll not follow this book specifically, but you may go to this book for references. And you may also find many references in the net. You can search if you have any doubt in any part. You can just go through in Google and type in your doubt. You will get what you want. You have to just search a little bit. And this documentation of Python is very important. You will always try to refer this documentation, python.org. You will get every detail, each and every detail in the Python documentation. And lastly, I will share the materials with you. You will always have this with you, and you can go back and refer it anytime you want, even after the course is completed. So you can download the materials which I am sharing, and you can keep it with you. Just a word of caution, the materials which I am making is not completely my own. I am referring some websites, some institutes, courses and all. So I will give the references. Just don't use those references directly. You have to cite those references. So just be careful with that. All right. So if you have any doubt in the first course handout, you can unmute yourself and ask questions, or otherwise we can move forward. Or any doubt in the course as a whole or something like that. You can always unmute yourself at any point in time and ask questions, and you can also say no, you don't have any doubt. So it will be an interactive session, then we will feel energetic. Otherwise it will just be a monologue from my end. I'll just say and I don't know you are listening or not. So you can unmute yourself and speak. All right.
So for my side, I don't have any questions so far. So we'll see how it progresses.
Thank you.
Yes, we can.
Oh.
We can continue.
So yes, so I am continuing with today's lecture. So this lecture one, it is focused on computational thinking. So yes, so just a minute, right? So this is the content of the today's lecture. We will see what is problem solving. Yes. Raghu, you are also unmute. I'm muting you if you don't have anything to ask. Yeah, so this is the content of today's lecture. We will see what problem solving is and how do we approach problem solving. Not us, our ancestors. How have they approached problems, and what framework have they suggested that we are still using till now for solving problems. We will delve deep into that, how problem solving has been approached and why computer science is all about solving problems. Then we'll see a little bit about algorithms and how algorithms are connected to problem solving, and then we will move on to this very good website which is made by MIT called Scratch, and we will have a very good interactive environment when we will see how programming can be visualized and put into practice. So this is the roadmap of today's lecture. So what is computer science? You see, computer science is a study of information, and how do we manipulate this information? So computer science deals with just information, and it also deals with the techniques and processes to manipulate the data or information which it receives. And here it comes where problem solving comes. So when problem solving is there, so if you have a problem, you have a methodical way, and with that problem you will have a lot of data with you, you will have a lot of information with you. So computer science is a field of study which explores those information and also have given a representation of those information. So for example, if you have written this alphabets here, so computer science COMPUTER, how are we representing this computer science, this alphabets in computers? That representation is also given by computer science. So those are generally represented in binary format. So you don't need to go there as far as this course is concerned. So I'm just talking about what computer science is about. So it explores information and it has given a representation of those informations. And then it talks about the techniques and processes which is used to manipulate information. And eventually you will come out with some output from that information. All right. So what computational thinking is? So computational thinking is the application of the ideas in computer science, and we use those ideas in problem solving. So you see, I have written computer science is a problem solving approach that breaks down complex issues into logic, algorithmic steps, promoting systematic problem solving application in various fields including computer science and beyond. So you may have a problem in your field, let's say arts or science or something else. So computational thinking is applying the ideas of computer science or problem solving in general, and you apply those ideas to the problem at hand, and you try to give an output, or you try to solve that problem. So this computational thinking can be applied to any field in general. All right. So now we are talking about problem solving. So we should think what problem solving is. So what is problem solving? Does any one of you want to mute and say what problem solving is? All right. So we will proceed. So you can mute yourself, by the way. There's no hard and fast rule that you cannot mute yourself. All right. Sorry, unmute yourself. Yeah. So problem solving is a systematic approach of identifying and resolving challenges or obstacles by analyzing, generating and implementing solutions. So you see, I have given a figure here. This is what a problem solving approach is. You have some input and you want to get an output. So you have a problem. The problem is your input and the output will be the solution of that problem. And in this black box is some abstraction. This black box is doing something to the input such that you solve the problem and the output which you got is the solution of that problem. So this is a framework of problem solving which has been followed from many generations and we are still following it. And this has helped us in our time to get to the time where we are, to the advancement of technology. This problem solving approach has been applied to every field of science, mathematics and whatever you can say. All right. So just problem solving is to taking a problem and you try to get an output. Now we'll see what is in this black box. So this black box is actually an abstraction. So before seeing what abstraction, what that black box is, we have to understand what is abstraction. So you see, an abstraction is a simplification process of a problem. It involves simplifying complex structures or problems by focusing on essential details while ignoring non-essential ones, allowing for some easy modeling or problem solving approach. So you are breaking that problem in step-by-step manner and you are only focusing on higher level things and not the lower level things. For example, you are driving your car from your home to work. So you are just focused on how to drive the car. You are not focusing on how the car is working. So when you are starting the car with your key, you are not thinking about what that key is doing, how the engine is running, how the wheels are turning. So you are not focusing on the lower level stuff. You are focusing on the higher level stuff. That is, you have to sit in the car, turn on the keys, then you have to start the car, change the gear, drive, and you have to reach the destination. Those are higher level concepts. You are not focusing on the lower level concepts. So this is a form of abstraction where you are only concerned with the essential details and you're ignoring the non-essential details. And by ignoring, I'm not saying that you're not, that non-essential details are not aiding you. They are aiding you, but you are not bothered about the non-essential details. And this abstraction helps simplify problems. So we will see two examples how abstraction is simplifying a problem for us. All right. So this is one example. You see, you are playing a video game, and in that video game, you have a player who can jump. All right. So when you press the jump button in the video game, your character jumps. You need not know how this complex details of gravity, muscle mechanics, or everything is working out. You are just seeing that you are inputting, you are giving an input, that is you are scrolling your finger up and you see, or you are pressing the jump button. This is the input and you are getting that you are getting the output as the character is jumping in the video game. So you are not focusing on the lower level implementation, how that character is jumping in the screen. So this is an abstraction, focusing on what is important, making your character jump. You are not focusing on how the character is jumping. All right. Ignoring the complicated stuff happening in the background. It's like using the jump button without being, I have written physics expert, it should be a computer science expert or something like that. So this is an example of abstraction in a video game. All right. Any doubts?
No, sir. No.
No, sir.
Okay. So one example I have given here is cooking. So most of you know what cooking is, so you can relate it well. So suppose you are cooking a pizza at your home and you have a microwave, sorry, not microwave, a convection oven. So you are taking that raw pizza and keeping it in the microwave oven and setting the temperature to some temperature, and you don't need to bother about what the inner working of the convection oven is, how the elements are getting heated, how the electricity is being converted into heat or something like that. You're just focusing on the input and output, and you know if you turn the knob, the convection oven will heat. So that is what you are focusing on. So you are focusing on the higher level implementation, and you're not focusing on the lower level implementation details. All right. So this is what abstraction is. So you are ignoring the things like heating elements, thermodynamics, airflows, etc. They are all modeled by some engineer and has given to you as a convection oven, and you just need to know how to operate that oven. So this is also an example of abstraction in real life, you can say. All right. Now we talked about abstraction. Now we'll see what is an abstraction in the black box. So in the black box, you have an abstraction of an algorithm. So in this black box, you have an algorithm, and that black box actually represents an abstraction of an algorithm. So you don't know what the algorithm is, how the algorithm is doing stuff. You just know it will do the stuff. You will give the input to that algorithm, and that algorithm will do its stuff and give you an output. So what I had represented earlier with a black box, this black box, when talking about problem solving approach, when you are applying it to computer science, this black box generally contains an algorithms, not in general problem solving, mind you. So problem solving approach is in general, it can be any problem, but when that problem comes to computer science, that black box represents an algorithm. All right. Now I have talked about an algorithm. So you should know what an algorithm is. So somebody would like to say what an algorithm is? If you have some idea what algorithm is.
Algorithms are kind of some codes under which the solving process is.
I couldn't understand. Sorry.
Algorithm is a sequence of steps to solve a problem.
Right. Thank you. So algorithm is actually a step-by-step procedure in which you are given some instructions, and if you follow those instructions, you will get an output. All right. So in general, these algorithms are applied to solve some problems. This is what an algorithm is. Now we will see an algorithm in two examples, how we make a cup of tea, and then we will see. So here I have written down the steps in English in the first example. In the second example, I have written the steps in pseudocode. All right. So let's see how an algorithm is applied to make a cup of tea. So what are your inputs? The inputs are a tea bag, hot water, sugar and milk. And what is your output? An output is a cup of tea. So what are the steps of the algorithm? You should boil the water first. You'll put the kettle. So these are instructions given by someone, and those instructions are an algorithm to make a cup of tea. So you boil the water, prepare the teacup. How will you prepare the teacup? The instructions are written. You take a cup, you put the tea bag, put sugar, put milk if you want. Then the next step is pour the hot water, let the tea brew for some minute, then remove the tea bag and stir. So these are the steps written in plain English for making a cup of tea, and you can say that this is what an algorithm is, step-by-step instruction to solve some problem. All right. Now we will see an example of looking a word in a dictionary. Suppose you are given a task to look up a word in a dictionary. So how can you do that? You can turn the pages one by one to go to that word. Suppose the word is tree. So you are starting from page 1 and you are turning one by one. So you see, this is a correct algorithm. You will approach that word in one point of time or not. But this is not a very good algorithm. Why? Because you will take a lot of time to get to that word. All right. This is one algorithm. What was that algorithm? Turn one page, check if that word is in that page or not. If not, then turn again. If you have found that word, then you have got the solution, or you have solved the problem. Now I'm giving you a second algorithm to look up a word. Turn two pages. When you find the word, then you output the meaning of the word. If not, then turn two pages again. So you see, this is a second algorithm, but it is not a correct algorithm. Although it is a fast algorithm than the first one, but this is not a correct algorithm. Why is it so? It is because you may skip the word because two pages are being turned at once. You can tweak this algorithm a little. So suppose that word starts with T. So when you come to P or Q, you can just start to turn one page again. So this will, with a tweak, become a correct algorithm. But you can have a more better algorithm in terms of time if you open the dictionary in the middle first and you see what word you are at. So what first character you are at. Suppose when you turn the book in the middle or the dictionary in the middle, you are at G. So you know T is in the right hand part of the dictionary. So you will take the right hand side of the dictionary and open the middle part. When you go to the middle part and you will see you will have a word, suppose P. So you know T is also again to the right hand side of the dictionary, and you will again open the middle part of that. So this is another algorithm to get to that word. And mind you, you will always approach to that word. This is a correct algorithm. And in general, we do something like that. And also a fast one. So I have given a technical diagram here. So we will not go into very much detail what this diagram says, but you can see with the size of the problem, the size of the problem means how many words are there in the dictionary. So suppose n words are there in the dictionary, and you see the time increases with the first algorithms. N describes, so if there are n pages in the dictionary, if we are saying n is the number of pages in the dictionary, then you will take n number of minutes or time units to solve that problem in general. With the second algorithm, with a little bit of tweak to make that algorithm correct, you will take n by 2 number of n by 2 times to solve the problem, because you are turning 2 pages at a time. So n pages are there, you will take n by 2 units of time to solve that problem. But for the third algorithm, you are actually taking log to the base 2 n number of times. So how are we getting this quantity is not important. The thing is, you can solve one problem in many ways, and each one has an advantage over the other. So you have to see what you need. All right. So the third algorithm is much better as compared to the first and the second algorithm. All right. So I have given a pseudocode of the algorithm. So what is a pseudocode? It is in plain English with some similarity with code. All right. So this is the pseudocode. Pick up the dictionary, open the middle of the dictionary, look at the page. All right. If the word is on page 1, sorry, not page 1. If the word is on the page, your lookup is complete. Get the meaning. Now, if you see the word is not there, what you should do? If the word is not there, you have to check if it is earlier in the dictionary or later. If the word is earlier, then open to the middle of the left hand side of the dictionary, right? Then you again go back to step 3. What you're doing in step 3, you're again seeing if the word is there in the page. If not, what will you do? If the word is there in the dictionary, you will get the meaning. If not, then you will see if the word is in the earlier or later in the dictionary. Suppose the word is in the later in the dictionary. What you will do, you will open the middle of the right hand side of the dictionary, and then again you will go back to line 3 and you will check if the word is there in the page, and again you will see if not, then what should we do? Either we should go to the left hand side or to the right hand side of the dictionary. Now this is not complete. You see, if the word is there in the dictionary, you will always come to this if statement. This is a technical term, if statement, and you will find the word and you will get the meaning of the dictionary. Suppose the word is not there in the dictionary. In that case, you have to give one more block, the else block, else quit. It means if the word is not there in the dictionary, you will perform all these iterations. It is also a technical term. You will perform the iterations. These are the iterations. Go back to line 3. And if the word is not there, you should eventually say the word is not there. That is, I have written quit. This is a general framework or the algorithm of the pseudocode of the algorithm which we had stated. to find a word in the dictionary. Now, if you have any doubt here, you can stop me and ask questions, and I will proceed forward from here. So, does all of you understood what this algorithm says and how it works?
Yes, sir, so far okay.
Yes, we are.
Right. So you see, we have some verbs here: pick, open, look, get, open. These verbs are nothing but functions. Those are an abstractions of doing some tasks. You are not bothering about the lower level details of those things. You are just saying pick up the dictionary. What this pick is doing, you don't know. Open the middle of the dictionary. What this open is doing, you don't know. Those are some functions. You are saying I will use those functions. So these are higher level details and these are abstractions. All right. Look, get, open. These are all functions. All right. Again, these are conditionals. If, else if, else. These are conditionals. You can understand it in plain English. If you get this, do this, else you get this, do this, else if you get this, do this, something like that. All right. So these are known as conditionals. We will see in our upcoming classes how Python uses these conditionals. Now, you see in each conditionals, I have a tab. There is some space, indentation is a technical term, indentation. So these indentations are important in Python. It may not be important in some other language like Java or C++, but it is important in Python, which we will see in our upcoming lectures. That is why I have given some indentation. What does that indentation means? It means that if this statement is true, then do this. If else this statement is true, then do these two things. All right. So this indentation are intentional in this algorithm. Now the next thing to focus here is these words. Sorry, not words, statements you can say, or expressions. Sorry. Yes. So word on page. So this will either give you a true or a false. If the word is there in the page, yes or no. Yes, the word is there, then do this. Suppose the word is not there, then this statement will give you a false. So these are called Boolean expressions in programming language. It can either give you a true value or a false value. All right. Again, in if else if statement, this one word is earlier in the dictionary, it will either return a true. Return is also a technical term. So it will either return a true value or a false value. Again, this expression is also there. Word later in the dictionary, it will either return a true or a false. All right. So we have seen three things: functions, conditionals, and Boolean expressions. Now go back to line 3. Can any of you say what this is? We have encountered this in our everyday life, but in programming language, what is it doing?
Maybe a loop.
Yes, these are loops. So we are going back to line 3. Sorry, I'm not using a pen here. So yeah, so when you come here, you go back to line 3 and then you start again. So these are loops. But you see, when you have to make sure that whenever you are encountering a loop or whenever you are coding a loop, there should be a end state or there should be a termination state. Otherwise, you may end up in a infinite loop, which means that loop will run forever. So that is taken care of by the statement 12 or line 12 and 13, which means if when all the pages are checked in the dictionary using this algorithm, if the word is not there, then you come here else and then you quit the algorithm altogether. So this two line is very important. When you see a loop, you should have some kind of I'm forgetting the technical term. So some kind of end state to end the loop actually. All right. So these are 4 things which we have seen: action based verbs or lines like pick up, look, open, get, which we will later call as functions. Second, conditionals, which is if, else, etc. are conditionals. The third is Boolean, the words like word in earlier in the dictionary or later in the dictionary or something like that, it will always evaluate to a true value or a false value, and it helps in decision making. And the fourth one is the loop. So in a loop, we have to do a task again and again. So we take the help of a loop. All right. So these are the four fundamentals thing which we have seen in this algorithm. There are more basic knowledge you have to have for doing programming language, like what are variables. All right. There are other statements also I don't recognize right now. So you have to have the knowledge of these before we proceed to code difficult tasks forward. All right. So if anybody has doubts here, you can ask. Otherwise, I'll move forward. So I'm starting with very basics. All right. If you don't have any knowledge of programming, you will be able to follow what I am teaching. In case you still don't follow, please don't hesitate to stop me. I'll try to solve the query. Yes. So I suppose everybody has understood what this is. Now we will see an IDE which is visual. So what is IDE? Integrated I'm not recognizing. So this is a programming building block. So this environment has been created by MIT, and this is a visual environment where you can use your mouse cursor and write code, and we will see these fundamental building blocks, these functions, conditionals, booleans, and loops implemented in Scratch. All right. So I'll move to this website. And in this lecture, I may not come to this slide anymore. So if you have any doubt, again, I'm asking, you can ask. All right. So I'll proceed. So this is a game which I have made in Scratch in the morning. So what this game is, so this is a ball and bowl, and a ball is falling, and you have to catch this ball. I can move the bowl with my arrow keys. The left key moves the ball left, the right key moves the ball, not bowl. The left key moves the bowl left, the right key moves the bowl right, and the ball is falling. I have to catch the ball. The score is there. So whenever you catch a ball, your score will increase, and when the ball hits the ground, your life is increased. So when you hit 5, the game is ended. All right. So I'm starting the game here. I have to catch the ball. So this is just a game. All right. So we will try to see how are we making this game. So if you see, when life is 5, the game is ending. So we are not trying to make the game. We will see how the fundamental blocks like functions, conditionals, booleans, and loops are being employed to make this game. All right. By the way, this is a very good platform for children to learn programming. So if you have any small child at your home, you can ask them if they are interested, or that is one thing. So if they are interested, they can come here and they can learn how to code. All right. So here we will see. So this is the environment of Scratch. On the left hand side, you will get some, you can say, blocks which you can use to code. So for example, move 10 steps. So when you write move 10 steps, this avatar moves 10 steps. All right. And when you drag it to the left hand side, it just vanishes or deletes itself. All right. Now this is the working environment in the middle. You have to write your code here, metaphorically you may say. And so in the left hand side, you have your workstation. You can select avatars from here. You can select these many avatars are there. Here you can select a background, and this is where the output comes. So whatever you do in the middle, you will see the output here. All right. So for example, suppose I want to have this cat say hello to us. So we will see how can this cat say hello using the concepts which we have used. All right. So we will go to lookup and we will say hello. All right. And then if we click hello, the cat says hello. But there is a better way to do this. When you go to event and you click this flag, so when this flag is clicked, this cat will say hello. And when this red button is clicked, the program ends, in a way you can say. All right. So what is this hello? Hello is actually the input. So if I go back to my slide, I said I will not go back to my slide. I'm sorry. Yes. So if I go back to the slide here, yes. So input of this function is hello. All right. And the black box here is actually, just a minute. Let me bring this here. Yes. So everybody can see my screen, right? I am not able to see the meeting actually. So I'm confirming once. You're able to see my screen.
Yes.
Yes.
So the input to this function is hello. So the input is hello, and this, yes, anybody is saying something? All right. So this black box here is say. So what this say is doing, we don't know. But how this say is doing, we don't know, but we know what it is doing. It will output a say bubble here. All right. So the output we know, the input we know, we don't know how the say block is working. But the MIT engineers who had made this game, they have implemented the lower level details of this function say. All right. So this is how this function is working. It is taking some input, doing something in background which we are not worried about right now, but we will see in our upcoming lectures, and we know what the output is. It will say hello. All right. Now I want to output my name here. So suppose I want to say hello, comma Shubham, and then I click the green flag. Now you see, when I am running this code, this is correct, hello Shubham. But when you run this code, you will not get the your name, because we have given the input initially in the function as hello Shubham. This, there may be some interesting thing. It may ask your name and then output your name. So let us do that first. All right. So when you go to, so I have come to this website and I have seen this section, so I can do it easily. It may take some time for you to be acquainted with this website. So I'm just dragging it here. So ask what your name is. So I'll just take it out, and when you take it there, you see it just magnetically stuck in place. So what is your name, and wait, it will ask you what your name is, and you see there is one answer. So what this ask block is doing, it is taking an input from the user and handing it back to the programmer. It is not handing back this answer. You will see what this answer is. Just give me 1 minute to explain. So it hand backs whatever the user is inputting to the programmer. The programmer can use this answer in some way and then output it. All right. So suppose we are saying say, we will put this say here, and we will delete this. And again, when you go to the operator, there is something called join. Yes, here it is, join. And I will say hello, comma, and I will delete this banana, and I'll put the answer here. All right. Now see what it is doing. You are asking a question first. So let us run the program. It is asking what is your name. So suppose your name is Sonu, and I'm giving the output Sonu. So I'm pressing enter. It is saying hello Sonu. All right. So it is a very simple program, but how it is working, you see, first come to this join function. It is taking two input, one input hello, other input answer, and what it is doing, it is also an abstraction. We don't know how it is doing, but we know what it is doing. So it is taking hello and taking answer and joining it. All right. Now you take this function ask. This is also a function. So you can just think about this. All right. So what this ask is doing, it is taking an input. So it is asking a question, and then it is not giving an output. It is taking that output and giving it back to the sorry, not user, it is giving it back to the programmer. All right. Now this output of this program is used by join. Again, the input will be hello and the answer from the output of ask function, and this join returns an output which is hello and whatever the answer is, and the output of this join is being fed to say. All right. So you see there are three functions, and each function has some input and some output, and there is interrelationship between functions input and output. The ask function has some input from the user. It sends the input output to join function. The join function has two input. One input is direct hello, and the other is input answer is from the output of ask function. It is joining these two blocks and giving an output. The output from join block is the input to say block. So the input is coming here, and what this say is doing, the output you will see here, hello Sonu. All right, so we have three functions, input and output. Input of some function is output of the other, and vice versa. I hope you have understood. I'll run it again. All right, so what is your name? Arjun. So hello Arjun. All right, there should be some space here. You see, I have not given a space. So hello and space answer. Now it will work. End it. Again you say Arjun, ARJUN. Now it is correct. Hello Arjun. All right. So I am asking doubt, but not whatever it is doing. I am asking doubt on how the input of one function is output of other, and the output of that function is input of other. If you have doubt in that concept, you can ask, or any other doubt per se. No doubt? All right. Now I'll give a technical term. The input to a function are generally called arguments or parameters in programming language. All right. So the parameters of join is hello and answer, and it is returning some value. So what return is, you will see in later lectures. All right. Now you have seen this. Let's make the cat say something. So if you go to the extension block and you will type text to speech, you will get this here, speak hello. Now what I'll do is I'll take the join block and I'll put it here, speak join hello comma answer, and I'll throw this say block away and I'll put it here, speak. Now this cat will speak. So you see, say block was a function, speak block is also a function. They are doing two different things. Say block is inputting a cloud or text cloud here. Speak will make the cat speak. All right, so I'll run again. What's your name? My name is Shubham.
Hello, Shubham.
I hope you could hear that. I could hear that. So can anyone of you confirm you could hear that or not?
Yes,
Yes.
I can hear.
Yes. All right. So this is a function. Now this is not what a cat does. They cannot speak. So let that cat say meow. All right. So I'll throw everything away and I'll come to sound and play meow until done. All right. So let me do it. Right. Okay. I'm sorry. The sound is a lot. Yes. So I want to make the cat meow 3 times. So I'll put 3 times here, meow. All right. The cat is doing it instantaneously. So let's make the cat wait for some time and then meow. All right. So what I'm doing is I'm putting wait for 1 second here. All right. Yeah, complete. Now it will do meow and wait for 1 second, again meow and wait for 1 second and again meow. All right. Now you see, we are repeating our code again and again. We are saying meow, wait, meow, wait. So this is not a very good practice in programming. You shouldn't repeat your code again and again. What should be the problem? Can anyone say what can? I know it is very easy, but it helps make the class interactive. So I'm asking, what can be a problem when you repeat your code again and again?
Code will be lengthy.
Sorry, I cannot hear you.
Code will be lengthy.
I'm sorry, again, I couldn't hear you. Okay, I'll tell you. So when you repeat code again and again, you might make some mistake in some block, or if you want to change some parts of the code in the repeating sections, so you have to make the changes in all the blocks. So that is why, and there are more reasons also, but these two are important reasons why you shouldn't repeat your code. So here, what we will do, we will use the concept of loop. All right. So when you come here, you see repeat 10 times. So we'll make this 3. It is a lot, 10 times. So we'll make this 3 and we will take this out and only take 2 of it here. All right. So this is a loop and we will throw this away. We don't need these two. And when we click green button, All right, this is a better code than the previous one. Why? Because we are using a loop. So you see, we had said here, we have seen, sorry, just let me go there. So we have seen what function is doing in that Scratch environment. We have not seen conditionals yet, but we have not seen Booleans yet, but we have seen loops. So we have seen functions, we have seen loops. All right, but the functions which we have seen is made by Scratch team, not by us. We can make our own functions. All right, and that is an example of abstraction. You see, you want to make the cat meow, but you don't want to get into the implementation details, how it is doing meow. So you are saying play sound meow, wait for 1 second. You don't want to get into the details. So what you can do is, sorry, you can make your own function. So let me go to the my block, make a block. All right, and I will say meow, meow. All right, I'll make a function meow. Now I have to define this function. So I already know what the function is, play sound meow and wait for 1 second. And I want to use this function. All right, you see, this is abstraction. So you don't know what meow is. You just take it anywhere in the environment and you need not worry about what meow is. You just come here, you know, when you press green flag, repeat 3 times what? A function meow. You don't know what meow is, but it can be understood simply by English language, or you know what the output of meow is, but you don't know how meow is implementing. All right, so when you press the green button, you will get the same thing, but you have used the concept of abstraction. All right, now you see, you can improve this function a bit. Just 1 minute, I have to bring this here. Yeah, you can improve this function a bit. Why? You may ask. You see, when you know this function is doing, or when this function is making the cat say meow, and you are repeating it sometime, the function might itself ask you what, how many times do you want the cat to do meow. So you can take this out and you can edit this function to take an input. Sorry. You have to right click and edit. You can give an input to this function. The input is here. You say n. So let the cat do n meows and give a text. We will say meow. Then it will be more clear for some user. All right. So I have made meow. Sorry. It will be times. Edit. It will be times. Meow n times. So I'm saying meow n times. It is n is coming here. So you see the definition of the function has changed. I'm sorry, I'm just clicking and it is making the sound. So the definition of the function has changed. It says meow n times. Now I have to put the repeat block here. I'll put the repeat block here. Sorry. Yes, and I'll put it inside the define block. You see, now if you put 3 here, it will do 3 times meow, but you have hard coded the function repeat 3 times. You have to say n times because n is the input to this function and that should go inside the function to work. So when you go to the variables, you will see n somewhere. Just a minute, where is n? You can take this out, right? So you have done it. So you see, you're defining n here and you are repeating that function n times. So you can just say repeat twice, 2 times, and you are not worrying about this function at all. You don't know what meow is. It is just saying when green flag is clicked, meow 2 times. It's very simple abstraction of a function which plays a sound meow for the cat. When you put 3, it will do 3 times meow. Yes. So I'm taking it back. So this is what abstraction is. Any doubt? I hope not. So you can ask. Yes. All right. Now we have seen an example of a function and also the functions which MIT engineers have made. We have also seen loops. Now we can go to conditionals. All right. So we will throw this meow. Yes.
Uh, are these two codes are running simultaneously or individually? Means there was one more, no, like which is consisting green flag, and second one which you have made.
So you
So
see
uh,
what
yeah, yeah,
it is doing. So you see when you write meow 3 times, this meow will go to its definition wherever the meow is. It may not be here. It may be in some library or something, somewhere else. It will go. It will call this function meow, and it will run that function whatever the code is in there in the function, and it will implement it and come back here. So I have written nothing below here. If I write something here, something like motion, so move -10 steps. So after this meow is completed, you see you will get it. Right, let us write minus, not -10, to visualize -30. So you see it will implement step by step. When green flag is clicked, it will meow 3 times. When this is implemented, then the cat will move 30 steps behind. So you see what is happening. And you can also see what it is happening by a halo effect in the code. So some yellow will come in, yellow border will come in the code. You see again, huh? So you see meow is happening, so yellow is coming here, and again here yellow will come, and it moves 30 steps back. All right. So I hope the
okay,
doubt
okay,
was clear.
yeah, yeah, got it.
All right. So now let us see conditionals. All right. So we will keep this here and we will throw this all away. Oh, first I have to throw meow away. That's why it's not happening. Yes. And I'll also throw it away. So now controls. So when we go to controls, so what I want to do is when I pat the cat or when I move the cursor over the cat, I want that cat to meow. All right. So I will bring if statement here. If something happens, do this. So this is an example of conditional. So what I want the cat to do, I want to cat, I want the cat to speak meow, all right, or meow. Now you have to have a true statement or a false statement here, a Boolean statement. What is the Boolean statement? If I pat the cat or if the mouse cursor touches the cat. So I have to see where is it sensing. Yes. So touching mouse pointer. If you bring it here, it will enlarge and fit it. You see, it is not the same size, but it is of the same shape. So it will help you understand where it goes. All right. It will just snap in place. Just a minute. It will just snap in. I'm sorry. Just a minute. Should snap in place. Yes. So touching mouse pointer. So when it touches the mouse pointer, play the sound meow. So I am pressing the green flag. It is doing nothing. But when the mouse pointer is touched, again it is doing nothing. Can you say what mistake am I making? Can anybody say? It's not a very difficult mistake to point out. Again I'll do. When I'm pressing the green flag, it is doing nothing, but when I'm taking the mouse pointer, it is not saying meow. What mistake am I making here?
To get the user input.
No, input is not there. You see, there is if conditional, and what it is checking if the mouse pointer is touching the cat. If it is touching, then play the sound meow. If it is not, so I have not given an else statement, so nothing happens. So again I'll press the green flag and I'll take the mouse pointer there, but it is not meowing. What problem am I facing here? What mistake have I done in my code, or bug? It is a technical term, bug. So what is the bug in my code? You can try. You may be wrong. No problem.
Because there is like kind of not other output, na? Like there is it is an incomplete condition kind of.
No, it is not an incomplete condition. I am saying if this happens, then do this. I am not stating what to do if the thing is not happening. All right. So you are not exactly correct. All right. So let me tell you what it is. So you see, these computers are so fast nowadays. So when I am saying, when I am pressing the green flag, this statement is executed instantaneously. So when I am pressing the green flag, it is checking if the mouse pointer is there in the cat or not. Since my mouse pointer is in the flag and this statements give false. Touching mouse pointer, so when I am touching green flag, how can I touch the cat? So the cat is not touching the mouse pointer. The statement is actually false and the program ends. Have you understood?
Yes, yes.
Right?
Yes, sir.
So what should we do? I'm sorry, yes. Anything else? So how, Acha, let me ask you, how can we improve this code?
You have to wait for the user input.
Yes, but it is difficult to specify how much time for the user to go to the cat. So what time should we wait for? So instead of saying wait for some time, we can give a loop. We can give a loop. Where is loop? Operations? No. Control. Yes. Repeat forever. So you can say repeat forever. Whenever the mouse pointer touches the cat, play the sound meow. Now it will work. So what it is doing, you see, yellow halo effect is there. So it is executing the code again and again and again and trying to see if this statement is correct or not, or if it is evaluating to true or false. So currently it is evaluating to false, but when I take the pointer to the cat, it will meow. All right. Now to end the code, I have to press this red button. All right. Any questions?
Isn't it CPU consuming? I mean, it will keep on running the code until we touch. Is
So
there a better way?
yes, we can specify one more thing here. So if the so you can say that if it is running for this amount of time, end the code. We can do that. So if the
Okay.
program is running for 10 minutes or so, you can end the code. That is not what I'm trying to convey with this. You can do that. It is very easy to do that. All right.
Okay. Okay.
Any doubt? So you see, we have seen functions, our own functions, and also the functions written by MIT engineers. We have seen conditional statements. We have seen Boolean expressions. What are Boolean expressions? I am saying touching mouse pointer. If actually what is happening is, you see, you have clicked this cat, and this cat is called sprite. So every character here is called a sprite. All right. So if this sprite is touching the mouse pointer, this statement means that if this cat is touching the mouse pointer, then it is checking true or false. All right. So when you add one more character, you can code for that character. So currently I am having only one character. That's why we are working for that character. So if that character is touching the mouse pointer, then do this. All right. This means that. So we have seen Boolean expressions. We have also seen loop statements. All right. Now I think most of the things which I wanted to do is over. Now I wanted to make the game with you, this game. If you want to see what are the steps to make a game, so what should be the steps? Again, in each step, what should be the lower level implementation? So over here, we have seen lower level, we have not seen the lower level implementation of the MIT code. In this game also, we will not go into the lower level implementation of the MIT code. We will go into the lower level implementation of this game. So if you have this game, we will see how this game is working. So we will code that game. That is what we will do. So I want to take a break of 5 minutes because 2 hours is a too long a time. And I may not require 1 hour full to complete this game. It will maybe 30 minutes or so, but still it is better to take 5 minutes break. Do you want to take a 5 minutes break or should I proceed?
Breaks. Breaks. Sir.
Okay. Okay. So it is 7:01. So we will meet in 7:06 or maybe 7:07. All right.
Okay.
Okay. Hello, am I audible? Hello, am I audible?
Yes, we are.
Yes, thank you.
Yes.
No problem. Yes. So yeah, so I was talking about this. Yes. Yes. So you see, I have talked about the game. I'll also show you once more. So whenever I press this green button, this ball falls from a random position. So it is not falling from the same position again and again. All right. So it is falling from a random position. When it hits the ground, it again starts from the beginning, or sorry, it again falls from the top. And if it hits the ball, then a score is increased by 1. One more thing, if this ball hits the ground, this life increases by 1. So what are the components of this game? So you have to have a background. You have to have two sprites. One is this bowl and the other is a ball. And you can move this bowl right and left. So when you press left arrow key, the bowl moves left. When you press the right arrow key, the bowl moves right. And this ball always falls down. It doesn't move up. So these are some few components you have to remember. All right. So we will make this game in 5 steps. What are the steps? The first step is we have to make this catcher. So it can be anything. I have just placed a bowl here. You have to make the catcher. Now you have to make this you have to make this catcher and make it move left and right. All right. Now you have to make this ball fall down and always go up. So these are two things you have to see. It must fall down. And second thing, when it hits the ground, it moves up. So these are two things. All right. First is the bowl. Second is the ball falling down. The second is when it hits down, it must go back up again in some random position. Fourth is catching the ball. So if the ball touches the bowl, we have to catch it. So it must not go past the bowl and hit the ground again. It must, when it hits the bowl, it must go back up again. So this is the fourth thing. And fifth thing is keeping the score and the life. All right. So we'll see how we'll make it. So I can open this code also, but let us not do that. I'll just open for my reference. Maybe I messed up something. So I'll make here everything fresh. I'll just delete this. All right. So any doubt with the game? I hope not. Well, yes, you can say. All right. So you see in the right hand side corner, I have a background. So I'll just pick the same background. There are many backgrounds to pick from. All right. I'm just picking this, and I'm again saying it is a very good platform for kids to learn coding. So you can ask your kid to explore this platform. Now I have a background ready. The first thing is the catcher. So I had taken a bowl. Let me catch. Sorry, let me take something else. So let me take this beer. I don't know why I took it. It is too large actually. Just a minute. The bowl is good. Let's not waste time. Yes, so I have placed the bowl here. Now we have to see that we have to move this bowl left to right. When I press left arrow key, the bowl should move left. When I press right arrow key, the bowl should move right. Now one thing you should note that this scratch environment has an axis. So in the center it is 0 0. In the left hand side, at most you can go minus 240. In the right you can go plus 240. In the top most you can go minus plus 180, and the top bottom you can go minus 180. All right. So 180 to 180, 240 to 240. All right. I messed it. Minus 180 to 180 and minus 240 to 240. All right. So this is the axis. So you can see x axis and y axis. So this is the ball. So what I have to do, if statement I'll bring, and I have to do motion. So move x, change x by. So change x by 10 units, 10 units to the right. So I have to see if statement. So Boolean expressions, sensing. If the bowl, Not ball touching should not be there. If space button is pressed, no. If right arrow is pressed, yes. So if right arrow is pressed, move the bowl to the right. So let me take the when green flag clicked. All right. Now again, I have to do this one more time. So I'll just copy and paste it here. When left arrow is pressed, change x by -10 maybe. Yes. Now you see this is not complete. Again, we will face the same problem. When we press green arrow, the code has run. So when I am pressing the left button or right button, the ball is not moving. So what I should do is I should make a forever block. So I'll keep a forever block, and when I do this, it automatically fits. Now it will work. So when you press the green button, the code is running. And see, when I'm pressing the right button, it is going to the right, and when I'm pressing the left button, it is going to the left. All right, any questions? Now when I press the red button, the game ends. Any questions? No questions. Any questions?
No, sir. No, sir.
No, thank you. So let me, I had taken a ball, so and I'm also confusing in bowl and bowl. So let me take egg or something else is there. Oranges. Okay. So you see, when I'm clicking this orange is highlighted and there is no code. When I'm clicking the bowl, there is code. So this code is only for the bowl. When I click orange, I have to write the code for orange here. All right. So what I should do, I told you the first step was to make the catcher. So we have made the catcher. Now we have to go to the second step, which is start the not ball here, orange at a random position in the top. All right. So we have to do that. Start the orange at a random position. So you should do go motion may you will have go to random position. All right. Go to at a random position. But when you do this, and we should say event, click green button. So when you click the green button, you see it can go to any random position, but I am saying it should go to random position at the top. So I'll also add motion and set y to -180, because that is the, sorry, not -180, 180. So that is the topmost position. So you see it will always go in the topmost position. All right. Now I have to see the ball is falling. So what I will do, I will go to the events block, not events block, control block, and I will say repeat forever, change y by -10. So when y is changed by -10, this should work. Not working because this should be inside when clicked button. So now you see it is working, but now we have again come to a problem because when it is hitting the ground, it is not going back again. All right. So now what should we do? This is the step where we have to see when it hits the ground, it goes back up again. You see, we have used a loop forever, but we have to give a if statement. If the ball hits the ground or reaches the ground, maybe it goes back up again. All right. So we will go to the control block and we will see if statement, right? If is here. Now in the motion, I'll say when x is not motion, this is a conditional, na? So I have to go to operator. So when y is something, y is actually, you have to go to y, where is y? In motion only you may have y. Where is y? Yes, y. So when y is less than equals to, you can say -170, because the bottommost position is -180. So we are saying that when y is less than -170, we can go to this, we can copy and paste, and we will delete this forever block, and we will say go back to a random position at go back to a random position at the top. So we cannot put it here. So we can again say an event when green flag is clicked. So you run it, you see what happens when it hits the ground. Sorry, why it's not working? Why it's not working? Anyone can see a doubt? Can see the problem here? Can anyone see a problem here? I don't know why it's not working. Just a minute. It should work.
Maybe both are starting simultaneously. So the second code should follow the first code.
Yes, you are correct. You are correct. Yes, when this is following the same, I should do this forever. So we have to check it forever. So you have to go to control, and you have to check it every time when it is hitting the ground. Now it will work. When green flag is clicked, yes, this should be there. Now it will work. I'm sorry for the confusion. Now it will work. All right. So when we are clicking the green flag, two codes are running simultaneously for this orange. It is checking if it is hitting the ground or not, and it is changing the position and also decreasing the ball's distance. So let me make this -5. It is changing very fast. It will be difficult to catch the ball. Now it is good. Yes. So we have done with the third step. So we are seeing if the ball is falling, and if it is hitting the ground, we are taking the ball up again. Now we will see if it hits the bowl. So we have see when it hits the bowl, it does nothing. It goes back down again. All right. So we have to see if the ball hits the bowl, then it should go back up again. Also, we have to keep the score. So let me take care of the score part after some time. We will see when it hits the ball. So again, we will go to a sensing, not sensing, control, if statement. So let me move the codes here forever. Check if statement touching the ball will maybe here, not here, sensing. If it is touching the bowl. So you see, we are coding for the orange. So we will say if the orange is touching the bowl. All right. If the orange touches the bowl, do something. What should we do? We will say that go back to a random position. So we'll make a copy of this and random position at the top. All right. So we will say whenever it touches the bowl, go back to a random position in the top, and let us make a sound also, something like pop or something like that. It will be pleasing. Yes, pop. And we have to also say whenever we click the red button, we have to run this code. Now it will work. Any doubt here? I'm just doing, I don't know you are understanding or not. Any doubt here?
No.
Not for me, sir.
Okay. So now you see when you touch the ball, a sound is played and the ball goes up again. And when the orange is not touching the ball, it is just going down. Now we have to keep the score. All right. So we have done with the fourth step. The last step is to take care of the score. Let me end this game now. And you can see variable. So we have not talked about variable in today's lecture, but we will see in the next lecture what is a variable. So let me make a variable named score, S-C-O-R-E. All right. And what we will do is we have to change score. All right. So let me give some space. So whenever the ball is touching, so we have to work with this code. Whenever the orange is touching the bowl, we have to keep a score. So we have to keep a score. Change my variable by 1. So after making the sound, change the my score by 1. All right. So you see the score is coming here. So whenever the orange is touching the bowl, change it by 1. But you should also see whenever the game starts, the score should be set to 0. So anywhere you can put over here or over here, it doesn't matter. Change the score to 0. Now I think the game will work. You see, the score is 0. When it touches the bowl, it increases by 1, and when it doesn't touches the bowl, it doesn't increase. All right. Now we have to also take care of the life part. All right. So if you have life or not, and so on. So you get the idea. So I'll show you the code. It's simple. So this is for the bowl we have done. For the ball, what we did. Let me not go here. Let me not go here because I have done some abstraction also. All right. So we will make another variable called life. So am I making it confusing? I guess, is there no hodgepodge now because I'm just speaking and I don't know you are understanding or not. It's clear, right?
Yeah, it's clear.
Yes.
All right. So we have to see life also. So we will see set life to 0. Whenever the game starts, set life to 0. Now, forever we are checking that if the ball is touching the block, the orange is touching the ball or not. We will again see if the ball is touching the ground. So let me make one more code, and control statement will bring forever we will run, and we will set the life. Let me set the life over here, because this is the code for life. Set life to 0, and we will check if sensing block, not a sensing block, sorry, control block, if statement. Now sensing block, this orange is touching the ground. So if it is touching the edge, yes, if it is touching the edge, we will go to variables, change life by 1, and also we have to check forever if the life is more than 5, again an if block, if the life is variable, sorry, condition होगा ना, just a minute, there will be a condition if अच्छा operator में होगा, yes. So if life is more than 5, variable, and we will bring life. If life is, let's say we will let 5, so we will give 4, because when it hits the ground it increases 1. So we'll make it, if it is more than 4, so when 5 comes it will be more than 4. So I'm keeping it 4 here. If you have any doubt here, you will understand in subsequent lectures why I'm keeping 4 and not 5. Stop all, where is stop all in the control? Stop all, so everything will be stopped. So this stop all is nothing but like pressing the red button, so it will stop the code. So someone was asking, it is not a good code if we say run forever. So this is some way to stop the code. All right. So I guess it will work when it is set to 0. Just a minute. Yes, it will work now. If it is touching the edge, no. If it is, I will not say if it is touching the edge, because the top portion is also an edge. So what it is doing, whenever the ball goes to the topmost edge, it is saying that it is touching the edge. We can say sensing, not sensing, we will say motion whenever y is, what is y variable? Whenever y is greater than something or less than something, maybe. Whenever y is equal to, no, whenever y is less than, wherever y position is less than 169. So why I am making this? I hope you have understood. If not, I'm saying what happened. So when I said when the orange is touching the edge, so this is also an edge and this is also an edge. So whenever the ball was going up, life was increasing, which we don't want. We want to check if the ball orange is touching the ground. So if the y position is less than minus 169, whenever the orange is going to a position which is less than minus 169, change life by 1, and also we will check this is all right. So you see this is all right. 0, it is touching the ground, life is increasing 1, again touching the ground, life is increasing 1, and so on. All right, this game will end sometime. So this is the complete code. Any doubt? Any doubt? So see, the game has ended, life was 5. Any doubt?
Sir, could you please repeat like how we had decided the experiments, like the coordinates of experiments?
So I am saying, see, this coordinate system in the center it is 0 0. All right, and that y-axis goes to 180 in the top and minus 180 in the bottom, and x-axis goes to minus 240 in the left hand side and plus 240 in the right hand side. So I'm not setting minus 180, I'm setting minus 169, somewhere a little bit up from the bottom. All right.
Okay. Yeah, got it. Thank you.
Any doubt? Now we can do one abstraction here. It is very simple. You see, go to random position and set y to 180. We have used 3 times, over here, and over here. So let us do one abstraction. Since we have learned abstractions, I am doing. Otherwise, the code is complete. All right, everything is done. The game is ready to play. You can just enlarge it over here and play the game. Whenever you press green button, the game starts and you can start the game. All right. See, score increases 1 again, so increases 1. When it goes down, life increases by 1. All right, so I'll end it. The code is complete, but you can just improve the code a little bit. What you can do, you can use the concept of abstraction. So we'll make one block. What the block will be, random or top, go to top position, go to top position. So this is also important, you should give the names of functions and variables such that it is easy to read and understand. All right, you can give x, y, z, something like that, but you should give a name which is easy to understand. All right, so let me define this function first. So it will be go to a random position and set y to x, and wherever I have used this thing, I will put this function over here. So again, here also I have used, just a minute, I'll just remove it. Again, I'll remove it, I'll throw this away, go to a random position, and here also I'll do, and throw this away and go to a random position. So this is a better code. All right, nothing, it is not important you do this, but this is just a better code. All right, so this is what the game was, and the concepts which we had talked about: functions, conditionals, and booleans, and what I missed, what did I miss? Conditionals, functions, loops, yes. So any doubt? We finished at 7:30 today. And by the way, you can ask your kids at home to play with this software. They will learn some ideas of programming and problem solving in general. Any doubt or anything you want to ask? Don't leave yet. I have one or two things to tell. Any doubts or anything you want to discuss? Anything you want specific to be taught or something like that?
I have a general question. So when I used to learn this programming in other languages such as C, C++, and all, that program used to run in a sequence. Like always, there will be a command on the top that will be followed by the command on the bottom, and it goes on. But when you showed here, there are 4 simultaneous programs running in parallel and all working together to give a final output.
Yes.
I feel this is a little bit different from what I learned before. Is there any significance of having this?
You are correct. Actually, this is a flaw of me. I have made this program such a way. You can change it. So whenever this green flag is clicked, but you see, some codes are here which will have to be in a separate cells, because the MIT has coded it in such a way. You see, forever block has nothing to go with because it will run forever. It has not given any stop block in there. So we can say if some iterations has increased, then come out of the forever block. So it is a limitation of this maybe, or maybe the limitation of me. I am not completely understanding the environment. There may be some way to do this, but what you are saying is correct. The code always goes step by step. It reads one line and then executes it. Again, it goes to the second line and executes it. It's either a flaw of me or there is some way around. I don't know, but you are correct. Anything else? So one more thing I wanted to tell you. So what you said is running one code specifically. So in a computer, when you are doing multitasking or simultaneously running many codes, so more than one program are running simultaneously. So you can think that in that line. So when you are doing this, so suppose what I am doing, I am running a meeting here simultaneously. I am browsing this PDF. I am simultaneously browsing this PPT, and I am simultaneously running this browser. So it is similar to that. All the codes are running line by line. So this has been done, this has been done. It is running line by line, but all these are running simultaneously in separate memory in the computer. Similar to what I am doing. I'm in a meeting as well as browsing or something like that. Am I making sense?
Okay, sir. Okay.
You can call me Shubham. It's not that you should call me sir. All right.
Okay.
Any doubt?
No.
No.
All right. So I hope you are finding this lecture interesting, maybe. So I wanted to start with this, although it is not important for our course, but the concepts which is taught will come back to those concepts and we'll see it individually. when we see it in Python programming language. All right. And the announcement which I wanted to do is the website is up. I will post that these recordings and this PPT and other material if I have in that website. And if you face any difficulty accessing those websites, please text in the WhatsApp group. I'll make another OneDrive or some cloud files, and I'll share that link with you. All right. And in case at any point of time you feel that you are not understanding, please feel free to stop me, and maybe I will not in that day, maybe in that next meeting I will clear your doubt if I was not able to clear your doubt in the previous meeting.
Okay.
Okay.
Thank you for joining. I hope you will be there at the end of the course and you will learn something in the course too.
Yeah, sure.
Yeah.
Thank you.
Yes, sir.
Thank you. And
Thank
please
you.
call me Shubham.
Thank you, sir.
Not sir, huh? I'm Shubham. Okay. Thank you. I'm
Okay,
ending
sir.
this meeting.
Okay, sir. Thank you.
Thank you.